So we're going to continue our discussion on classifying matter. We went over one classification, which was pure substances. Today we're going to go over the other classification, other major classification, which is mixtures. And under mixtures, there are two other classifications. They're what we call heterogeneous mixtures and homogeneous mixtures, which are also known as solutions. Heterogeneous, different. So when you mix two pure substances together, and when you look at that mixture and you can easily tell the one material from the other, or all materials from all other materials, because you could have more than two things in a mixture. They call these materials in a mixture, they call them phases. If you can differentiate between the different phases, you can tell the difference. It's called heterogeneous, different in different places. Simple illustrations for this. I have, again, our friend sulfur in a dish, and I have in this iron filings, so little bits of iron. In here, if I can open it, here we go. And what I'm going to do is I'm going to put a little bit of the iron into the sulfur. And we'll take that iron and sulfur, and I'm going to, wow, almost dropped it, but I did. I'm going to mix it around. And you can see, hey, there's little bits of iron, there's a little bit of sulfur. It is mixed together. This is a mixture. It's heterogeneous. I can easily tell where the iron is and where the sulfur is. The thing about mixtures is, no matter what kind of mixture it is, there should be a process to be able to separate the mixture through what we call physical properties. Now, we're going to get into physical versus chemical properties a little bit later. But physical properties are properties that obviously we can describe the material, but also different, how can I say this? Different materials have different physical properties which allow us to cause separation. For instance, maybe it's by example will be better. I have a magnet. And magnets only work with certain metals, iron being one of them. So if I take my sulfur and my iron and I bring my magnet nearby, I can easily move the iron and separate it out of the mixture. I can bring it up. Now if I wanted to, I could take my magnet and I put it right in here, and I can bring out the iron. Now there's a little sulfur attached, but that's fine, I can dust that off. Because for the most part, sulfur is not magnetic. So I'm using magnetism, a physical property, to separate the mixture. Now, we can take, well, this gets a little messy. We can take iron and sulfur. I can put them into a beaker. And I can even mix that with another material. I can pour that with some water. And all I'm going to do is make a mess. Because the water, the sulfur, and the iron, they just don't mix. You can tell there's different parts of solution everywhere. I can see the water, I can see the iron, I can see the sulfur. Heterogeneous. How can I separate this? Well, I'll give you, 5 seconds. How can I start to separate the iron, the water, and the sulfur? Well, we already know how to separate the sulfur and the iron. I can get rid of the water. Right. Evaporate it, boil it, let the water go away, or we try to recapture it somehow, but we can separate this. Now, lots of different heterogeneous mixtures all around us, everywhere, and we're going to go over practice later. it's pretty easy to identify a heterogeneous mixture when you hear it. One of the famous ones on some of the worksheets are like Rocky Road ice cream is heterogeneous. Dirt, because there's all kinds of stuff in dirt. You get the idea.